Good morning, everybody. Happy Monday. Today we're going to be talking about matter. Our I can statement of the day is I can explain what matter is and the three different states: solid, liquid, and gas. What is matter? Matter is what everything is made out of. You, your chair, this computer, it's all made out of matter. Matter is made of the atoms, which come from the periodic table of elements. You probably have heard of this before, periodic table of elements. So here's what it looks like. Basically, what this is it's a table, and it tells you all of these little letters are abbreviations for elements that come from the earth naturally, which means they're already here. We did not create them. So these are all the elements that come from the earth naturally. These elements can be broken down to atoms. So atoms is their basic unit of chemical element. So this has our positive and negative charges. It's basically what everything is made out of. That comes from these periodic table of elements. And then we have a molecule. So a molecule is a group of atoms bonded together. So the best way I like to think of this is if we look at the elements, we know that water is H2O, right? So our H would be our hydrogen, which is number one. So H, we know we have two of those, and oxygen. So when we put the atoms hydrogen and oxygen together, we get H2O, which is water, which is a molecule because we have more than one atom bonded together. So the atoms would be the hydrogen and the oxygen. When we put them together to make water, H2O, we would have the molecule H2O because it's a bonded group of atoms. So matter is the different phases or shapes that the groups of bonded molecules can take. So we know that H2O can have different states of matter. So we know that water can be a solid, a liquid, or a gas, and we're going to go through the examples like that. So for example, when we have H2O in a solid, it is a firm and stable shape. It cannot change shape. So if you look at this picture right here to the left, it says water molecules and solid ice. So when we have a solid, the molecules are very structured. They're in nice little neat rows. They don't really move much. They just stay in one place. They're very organized. When we go to a liquid is a substance that flows freely but has constant volume. What that means is if I have a glass of water and I pour it into a different glass, even though it might look like more or less, it's the same amount of water. Just as if I take that same water, I pour it on the ground, it's still the same amount of water. We're not going to magically have more or less water. In this picture, you can see when the water molecules now are kind of free moving. They're not all facing the same direction. They're not as organized. They're still pretty close together, but they kind of shift around a little bit compared to this picture when they're in those perfect rows. And then we have a gas, and a gas is a substance or matter in a state in which it will expand freely to fill the whole container, having no fixed shape or volume. So gases are constantly changing and expanding. This is going with the water example. This is like when you boil water and you get steam. That steam is condensed at first, but eventually it goes throughout the whole room. My best example for when we think about gas is think about if you had a really stinky pair of socks, right? And would you want to bring that stinky pair of socks into a really small room or a really big room? Right? If we were in a really small room with a really stinky pair of socks, that gas would fill the room, but it wouldn't have too many places to go because it's going to fill the room. And if it's a small room, it's going to be pretty condensed and we're still really going to smell it. But if we move with that stinky pair of socks to a huge room, like a giant basketball stadium, right? Are we really going to be able to smell the stinky socks? No, because that gas is going to expand throughout the entire basketball stadium, right? It's going to fill the whole container, in this sense being that whole room. So it's not going to be as condensed, and those molecules are constantly moving super fast. They're far apart, and they're bouncing off the walls. That's all I have for today. Yeah.